Okay, so try and do 4 more. This will be a long video to get through G, H, I, and J for other complicated chain rule mixed with either quotient rule or product rule. I think these are all quotient rules. So the formula's complicated and it's going to be a bit of a challenge. So hopefully you can pause this and follow all my steps if I explain them properly. Alrighty, so I'm seeing something complicated inside this bracket all to the third power. So I'm going to treat this like it's a chain rule to do the derivative. So the derivative of this function, I'm going to take the 3 out, keep this entire bracket the same, x plus 2 over x minus 2, reduce the power by 1, but then you have to multiply by the derivative of what's inside this bracket. And the derivative of what's inside this bracket is a quotient rule, because there's f on top and g on the bottom. So I'm going to do f prime g minus fg prime over g squared in this black bracket here. So f prime, the derivative of x plus 2 is 1. F prime g minus f g prime all over x minus 2 squared. Okay, so what you're going to see me do a few times in these questions when you have multiple fractions, I'm going to leave the 3 here. I'm going to break this square onto both terms, and you'll see why in a second. So I'm going to call that x plus 2 squared on top, x minus 2 squared in the bottom. Then I'm going to multiply by this other fraction that you see. So here you have x minus 2 minus x minus 2 on top, because the negative distributes in. And in the bottom here I have x minus 2 squared. So on my next line, I'm going to combine these fractions. These two guys can get together. X minus 2 squared and another x minus 2 squared means in the bottom, I'm going to have x minus 2 to the 4th. I still have x plus 2 squared on top. And now I'm going to deal with this bracket. X subtract by x makes 0. Negative 2 subtract another negative 2 makes negative 4. So then we can grab these coefficients, put those together, and get negative 12 x plus 2 squared over x minus 2 to the 4th power. Question you generally ask at this point is, am I done? I don't see a common factor in the numerator or denominator, and I don't see any negative exponents. So that's the way I would leave that question. It's just as it is right there. That's the formula that will give you the slope of the tangent line anywhere on the curve. All right, down to, well, I'm going to take more room on that one, I guess. Down to h. Similar question. The power is bigger, and there's a t squared in t this time, but my overall method is going to be very similar to doing this question. So I see a bracket to the 10th power. I'm going to treat it like a power rule at the beginning. 10, keep the bracket the same. T squared plus 1 over t plus 1 to the 9th power. Then you have to multiply by what's in the derivative of what's inside this bracket. Again, the top part of that fraction is f. The bottom of that is g. And I'm going to do the f prime g plus fg prime over g squared in this bracket. So f prime, the derivative of t squared plus 1 is 2t. F prime times g. G is t plus 1. I put plus, but it's supposed to be subtract. Glad I caught that. So minus f is t squared plus 1. G prime, derivative of t plus 1 is t, all over t plus 1 squared. Same as last time, I'll distribute that 9 onto both terms. T squared plus 1 to the 9th over t plus 1 to the 9th. And on top in the second bracket, distribute 2t squared plus 2t minus t squared minus 1. And in the bottom, t plus 1 squared. I will put those two together, like I did last time. 10 t squared plus 9, or plus 1 to the 9th on top. T plus 1 to the 11th on the bottom. 2t squared, subtract 1t squared is 1t squared, and 2t and minus 1. So when I look here, I don't see common factors. You would very quickly examine this trinomial here, this quadratic. Could you factor it? It's not t plus 1 squared, it's almost that, so you'd look and see if you could factor it. It does not factor, and so you are done with that step right there. So, going down to our next one. For I, you have an equation that says square root of x squared minus 1 over x squared plus 1. So before I take a derivative, that's a power. That is x squared minus 1 over x squared plus 1, all to the 1/2. So I'm going to treat this just like the previous two questions. To get this derivative, I'm going to take the power down. Excuse me. I'm going to keep the bracket the same. I'm going to subtract 1 from the power. Then I'm going to take the derivative of what's inside. The top term is f. The bottom term is g. F prime g minus fg prime over g squared is what goes in this bracket I'm about to write. So f prime is 2x, g is x squared plus 1, minus f is x squared minus 1, g prime is 2x, all over the denominator squared, which was x squared plus 1 squared. Okay, now I'm going to do a nice, neat little trick. So, the trick I'm about to show you, and I'll do it over here in blue, that if you remember a negative exponent means to take it downstairs. So I'll do it with something simple. If you had 1 over 3 to the negative 1, that means you're going to write this as 1 over 3 to the plus 1. Okay, just like if you had x to the minus 1, it would become 1 over x to the plus 1. You just drop the bracket downstairs. Well, now if you had 1 over 3, you would take this bottom fraction up, you would flip it over and multiply, and so you would get 3 over 1. So if you notice, if you have 1 over 3 when you start to the negative 1 power, that becomes 3 over 1. So when you see a negative exponent and there's a fraction there, you can just flip it over. So watch what I'm going to do here. dy by dx equals, I'm going to keep the 1 on top. Actually, I'm going to write it this way. It's 1/2. I'm going to flip this fraction over. put the x squared plus 1 on top, the x squared minus 1 on the bottom, and make it to the positive 1/2 power. Flip it, because this shows me I can just flip it. So when you have a fraction to a negative power, flip it over. I'll distribute the 2x and get 2x3 plus 2x. I'll distribute this 2x and that negative and get minus 2x3 and plus 2x over x squared plus 1 squared. So now if I try to break this up a little bit, on top I'm getting a x squared plus 1 to the 1/2. On the bottom I'm having a 2 and x squared minus 1 to the 1/2. So I broke this power up to the two of them. I kept the 2 downstairs and the 1 upstairs. 2x squared minus 2x cubed minus 2x cubed is gone, and 2x plus 2x makes 4x. On the bottom over here I have x squared plus 1 squared. Okay, so now there's a couple of things that could cancel. The x squared plus 1 on top and some of the x squared plus 1's on the bottom, I'm going to group them together. I also see a 2 here, and part of that 4 is going to cancel and leave a 2. All right, so then in my bracket, I'm going to have this x out front right here. So I'm going to write x and a 2. I don't know why I didn't put the 2 as well. So I'm going to have a 2x. Now, I'm going to, what you do with your powers is you subtract them, right? So you have x squared plus 1, you had 1/2, and you subtract 2. So 1/2 minus 4 over 2 is negative 3 over 2 as the power. And in the bottom now, all I have left is x squared minus 1 to the 1/2. Question is, am I done? Or are I done? No, am I done? Am I finished? Negative exponent has to go downstairs. 2x over the x squared minus 1 to the 1/2 is downstairs, and now the x squared plus 1 to the positive 3/2 is downstairs as well. And that gives you the derivative for this complicated beast. Now for the last glorious question for us to tackle. You have an expression here. You've got something cubed on the top. So I see straight up an f and a g. So my f term is 2x plus 3 to the 3rd power. My g term is 4x minus 7 to the 1/2 power. So my f prime is going to be, drop the 3 down, 2x plus 3 to the 2 times the derivative of what's inside. So f prime is 6 bracket 2x plus 3 squared. That's my f prime. G prime is going to be 1/2 4x minus 7 to the minus 1/2 times the derivative of what's inside, which is 4. 1/2 and 4 makes 2. 4x minus 7 to the minus 1/2. Negative exponent means drop it downstairs. So g prime is 2 over square root 4x minus 7. So I'm going to assemble that all into my formula for the derivative, which is going to be f prime g minus fg prime over g squared. So dy by dx is f prime, which is 6 bracket 2x plus 3 squared, times g, 4x minus 7 to the 1/2, then minus f, which is 2x plus 3 cubed, times g prime, and I didn't leave myself a lot of room here, so scooch that down just an inch. Okay, f times g prime, which is 2 over square root 4x minus 7. All over g squared, which is the square root of 4x minus 7 squared. Okay, so if I think, and I go back to this line, because I want to take a common factor out, I'm actually going to go up to this line that's up here, and I'm going to move this back upstairs because it is a negative exponent, and you're going to see why in the next step. So if you can, I'm going to go back up here and change this. I'm going to scratch it out, and I'm going to put in the 2 bracket 4x minus 7 to the minus 1/2. I'm going to put this line in its place. And hopefully, if you follow me for doing that, the reasoning for that is going to be so that this can actually look just a little bit easier for a common factor. Okay, so we'll take this part here, move it down into its place, and that's what g prime would have been. The reason for that is because now I'm searching for common factors. There's a 2 in here, 2 times 3, and a 2. So you've got, by the way, 1 term here, 2nd term there. So there's a 2 in common that I'm going to pull out. There's a 2x plus 3 squared in common that I can take out. And there's a 4x minus 7 to the negative 1/2 that I will take out because it's the smallest power. So my first line then, what I'm going to take out, I'm going to take out a 2. I'm going to take out 2x plus 3 squared. And I'm going to take out 4x minus 7 to the minus 1/2 power. In the numerator, I'm taking all that out. That will leave this 3 behind. That will leave 4x minus 7 to the 1/2 minus minus 1/2 means to the 1. Subtract. I took 2 of these 2x plus 3's out, so that leaves a 2x plus 3 behind. The 2 went away, and this term went away. In the bottom, I have 4x minus 7 square root squared, just leaves 4x minus 7. Time to play around a bit with this bracket. So I will get 2 bracket 2x plus 3 squared. Let's move this down now. It's a negative exponent. Let's shove it downstairs. So I'm going to get 4x minus 7 to the 1/2 and another 4x minus 7. And that square bracket up top is a 12x minus 21, and then distribute the minus sign, you get minus 2x minus 3. 2x plus 3 squared. 12x minus 2x is 10x. Negative 21 and minus 3 is negative 24. And in the bottom, I see 4x minus 7 to the 1/2 and 4x minus 7 to the 1. They're the same base, so I'm going to add the exponents together. 1/2 plus 1 is 3/2. So you will get 4x minus 7 to the 3/2. Again, you're about to ask me, how do I know if I'm done? There's no negative exponents anywhere, but there is a common factor in this bracket. 5x minus 24 is 2 onto 5x minus 12. So I will take the extra 2 out of there, and this will become 4 bracket 2x plus 3 squared, 5x minus 12 over 4x minus 7 to the 3/2. So the good and bad news to these questions, the bad news is these are very complicated algebra steps. The good news is these are the hardest questions to do in the course. Right here is the hardest parts. You have to take your time and go at it slowly, but it really doesn't get more challenging than these derivatives. These derivatives are difficult, and they're really just, I'm going to make up stupid hard questions for you to see if you can do those derivatives. And by getting through these types of functions that are chain rule with quotient rule and chain rule with product rule, you're then ready for pretty much every type of derivative that we can possibly give you, combining those rules together. So hopefully this has set you up for some of the complicated ones that you're going to get either out of the textbook questions that we further ask or on that assignment that's coming up.